With a double bomb bay that could carry a massive 16,000 pounds of bombing ordnance to a target 2,000 miles away, and return to base, the Boeing B-29 Superfortress entry into the Pacific theater of World War II in 1944 was a game-changer. Their subsequent positioning in Mariana Islands air bases within striking distance of mainland Japan would bring an end to the war in the Pacific, cementing their place in history as unquestionably the most formidable and the most consequential bomber in aviation history. But its path to fulfilling this destiny was far from smooth. More of that soon. For now, let's take a closer look at this remarkable aircraft. With a wingspan of 141 feet, a length of 99 feet and a standing height of 27 feet 9 inches, driven by four Wright R3350 duplex Cyclone 18-cylinder, air-cooled turbo-supercharged radial piston engines delivering 2,200 horsepower each, the B-29 had a cruise speed of 220 miles per hour, increasing to a maximum of 399 miles per hour at 30,000 feet. They had an empty weight of 74,500 pounds and a maximum takeoff weight of 133,500 pounds. The B-29 had a crew of 11, the pilot, co-pilot, bombardier, flight engineer, navigator, radio operator, radar observer, right gunner, left gunner, central fire control, and a tail gunner. Armed with the General Electric auto-computing fire control system, composed of 8 remotely controlled 50-caliber machine guns installed in 4 barbettes located on the top and bottom of the fuselage, fore and aft. Later models added 2 more machine guns to the top forward barbette to assist in defending against frontal attacks. Control of the 4 barbettes could be transferred to a single gunner or shared between the front, right, left, and top gunners. All weapons were aimed optically, with targeting computed by analog electrical instrumentation, increasing the weapon's accuracy by compensating for factors such as airspeed, lead, gravity, temperature, and humidity. The tail gunner manually controlled 2 more 50s plus a 20mm cannon. Boeing's first problem in building an aircraft to meet the bomb delivery specifications presented by the US Army Air Corps was finding a wing to lift the giant fuselage needed. Any given existing wing design would have enough lift, only to have too much drag at cruising speed. Another would have low drag but unacceptable stall characteristics. Yet another would have low drag, good stall characteristics, and not enough lift to get the plane to take off on any runway of reasonable length. Boeing determined to design its own wing, designated the Boeing 117 wing. When the wing design was finished, it was 141 feet long and had an area of 1,736 square feet. It was designed with a set of flaps, which would increase the wing area by 350 square feet, for better control at slower speeds. With the flaps retracted, the wing had very low drag, which permitted higher speeds. Boeing then devised a way to manufacture 2 wing spars, which were the longest and heaviest duralumin extrusions ever made. During destruction testing of the Boeing 117 wing, it took 300,000 pounds of pressure to force its collapse. Another significant challenge pertained to the comfort and well-being of the crew during extended flights. The exigency of this issue was heightened by the Superfortress's substantial flight range and endurance capabilities. Unlike its smaller bomber counterparts, which had limited range and therefore less demanding requirements for crew comfort, the Superfortress was designed for operations that could keep the crew airborne for as long as 18 hours. Furthermore, it was capable of reaching altitudes up to 32,000 feet, where temperatures could plummet to 50 degrees below 0 Fahrenheit. Given these harsh conditions, it became imperative that the crew compartments of the Superfortress be pressurized to ensure a livable environment. However, this posed an intricate engineering dilemma. The necessity to pressurize the aircraft conflicted with the requirement to open a substantial 40-foot segment of the fuselage to the external air pressure at high altitudes for the purpose of bomb deployment. Ultimately, the solution materialized in a novel engineering design. The areas both forward and aft of the dual bomb bays were pressurized, thereby creating isolated, habitable spaces for the crew. To enable mobility between these sections during flight, a large tube was installed above the bomb bays. This innovation allowed the airmen to traverse from one part of the aircraft to the other, while still facilitating the release of munitions from an unpressurized center compartment. Then there were problems with the huge 16.5-foot Hamilton Standard propellers, which caused runaway engines, problems with the 4 remote-controlled gun barbettes, problems with the fire control blisters, where gunners were stationed to aim the barbettes. The blisters sometimes blew out when the craft was pressurized and flying at high altitude. Gunners were advised to wear a safety line in order to avoid being blown overboard if a blister popped. Then there were problems with the booster controls for the rudder and issues with the radar systems. But, despite all this, finally on Monday, the 21st of September 1942, the B-29 prototype XB-29 was rolled out on the runway at Boeing Field, Seattle. Eddie Allen, Boeing's chief test pilot, lifted the first Superfortress off the runway, performing all flight controls successfully in a 3-hour fight. The second prototype flew 3 months later. However, as a measure of the problems yet to be solved, in the 97 days following that first flight, Allen was able to accumulate only 27 hours flight time in the prototype. The most relentless problem were with the 4 2,200 horsepower Wright R-3350 duplex cyclone engines. They persistently overheated, swallowed valves, and even caught fire in flight. To produce more horsepower from a lighter engine, the crankcase was made of magnesium, a very light, very strong metal. The problem was, magnesium is also a flammable metal. When that was combined with the additional problem of a fuel induction system, which tended to catch fire and burn long enough to catch the magnesium afire, it became a very serious situation. Band-aid treatments such as air baffles to direct more air to the rear row of cylinders and propeller cuffs to force more air through the engine helped, but it would be an ongoing problem until the aircraft was fitted with the more powerful Pratt & Whitney R-4360 Wasp Major in the B-29D. Sadly, this fault caused tragedy on Thursday the 18th of February 1943. Eddie Allen was flight testing the No. 2 XB-29 prototype when an engine fire developed. The port wing spar burned through and collapsed, sending the huge bomber crashing into a meat-packing plant a few miles south of Boeing Field. All 11 crew aboard the plane and 18 workers in the plant were killed instantly. Changes to the production craft came so often and so fast that in early 1944, B-29s flew from the production lines directly to modification depots for extensive rebuilds to incorporate the latest changes. AAF contracted modification centers and its own air depot system struggled to handle the scope of the requirements. Some facilities lacked hangars capable of housing the giant B-29, requiring outdoor work in freezing weather, further delaying necessary modification. By the end of 1943, although almost 100 aircraft had been delivered, only 15 were airworthy. While the basic design of the B-29 was sound, significant shortcuts had been taken in the rush to get it into service, causing numerous defects and quality problems. And the Boeing Run organization, which should have been getting the B-29s ready for battle, had effectively collapsed under the strain. This prompted an intervention by General Hap Arnold to resolve the problem. In March 1944, General Bennett Myers was given full authority to act under Arnold's name to get the B-29s modified and combat ready. Specialist USAAF ground crew and technicians were called in from all over the country, and 600 workers were pulled from the Wichita assembly lines. Subcontractors were told to stop all work on non-B-29 components until they had fulfilled their commitments. In what became known as the Battle of Kansas, work was round the clock, outdoors in the freezing Kansas winter weather if necessary, so that 150 aircraft were modified to airworthiness in the 5 weeks, between the 10th of March and the 15th of April 1944. The Superfortress was ready. In April 1944, B-29 Superfortresses started arriving at their designated airbases in Bengal, India, specifically in Kharagpur, Chakulia, Piadoba, and Dudkundi. Concurrently, the 20th Air Force was created as an autonomous unit, mainly to ensure that local commanders such as Stilwell and Chennault could not redirect the B-29s from their primary objective, to bomb Japan. The aircraft continued to face recurring issues with engines overheating and catching fire, problems that were worsened by India's scorching 115-degree heat. By May, 130 B-29 Superfortresses had arrived in India, and the forward staging bases near Chengdu, China, were functional, albeit just barely, and due to the corruption of local officials at great expense. However, transporting the necessary fuel and ordnance to Chengdu across the Himalayas proved to be a perilous and inefficient endeavour. On June 5th, the Superfortresses conducted their inaugural bombing mission, targeting the railway yards in Bangkok. Hindered by mechanical issues and adverse weather conditions, the operation was far from successful, with only 18 bombs reaching the target. Amid mounting pressure from Washington, General Wolfe, the commanding officer of the 20th Bomber Command, was urged to focus on Japan by mid-June. During the night of June 14th, a fleet of 92 B-29s departed from forward bases in China, aiming at the Imperial Iron and Steel Works in Yawata, a critical facility responsible for producing a quarter of Japan's rolled steel. Of the 92 bombers launched, only 47 made it to the target in Yawata. 15 engaged in visual bombing, while 32 used radar due to weather issues. Only one bomb hit the target. Although the raid had minimal material impact, it was lauded by the media as a significant victory, marking the first US bombing attack on Japan since the Doolittle raid in April 1942. Subsequent Matterhorn missions persisted but with limited effectiveness. On July 7th, 18 bombers struck Japanese cities. 2 days later, 72 Superfortresses targeted a steel plant in Manchuria, followed by more unsuccessful raids in August. On August 29th, 38-year-old General Curtis LeMay took command of the 20th Bomber Command. Nicknamed Iron Ass, and known for his no-nonsense cigar-chomping demeanor, LeMay initiated several changes. He ramped up training and mission frequency, restructured the flights into 12 aircraft formations, introduced the lead bomber approach, and reorganized bomb groups. Despite these efforts, missions threw the full faced challenges including supply issues and improved Japanese air defenses. By the close of 1944, 147 Superfortresses had been lost due to enemy fire and accidents. As a result, Operation Matterhorn was deemed ineffective and subsequently discontinued. US military strategists recognized early on that the Marianas Islands, Saipan, Tinian, and Guam, located roughly 1,500 miles south of Tokyo, would serve as strategic bases for launching B-29 assaults on Japan. By the summer of 1944, these islands were secured and airfields hastily constructed. The 21st Bomber Command was established to oversee Marianas-based B-29 operations. Following initial training and some preliminary missions, 111 Superfortresses targeted the Nakajima Aircraft Company's Musashi engine plant near Tokyo on November 20, 1944. Despite ongoing efforts, the raids against both the Musashi and Mitsubishi engine plants in Nagoya remained largely ineffective through the end of the year. Bombing accuracy had been miserable because of the high winds at the 28,000 to 34,000 foot level. Curtis LeMay was once again called upon to revise the strategy. Having studied the Japanese economy's reliance on small decentralized cottage industries, within large cities, he shifted the focus from high-altitude, precision bombing of individual targets to a scorched earth policy aimed at decimating entire cities, along with their industrial capabilities and civilian populations. LeMay's approach was radical. Instead of carrying high-explosive bombs, the B-29s would be loaded with incendiaries. To conserve fuel and increase bomb capacity, the aircraft would be stripped of their guns and would fly at altitudes of 5,000 rather than 30,000 feet. Flying directly to their targets, without the need for circling and formation assembly, each Superfortress could carry roughly 7 tons of M69 incendiary bombs. These raids would be conducted at night, capitalizing on the weaker capabilities of Japanese night fighters. The impact was cataclysmic. On the night of March 9th, 279 B-29s unleashed hell on Tokyo, sparking a massive firestorm that turned 16 square miles into ashes and killed 84,000 Japanese citizens. Similar, albeit less devastating, outcomes were achieved in subsequent raids on Nagoya, Osaka, and Kobe, with only 20 B-29s lost. Incendiary raids resumed in April after resupply and continued with unrelenting intensity, decimating the industrial zones of major Japanese cities. By mid-April, Japan's ability to manufacture aircraft engines had been obliterated. Further B-29s were deployed to the Marianas, including units from the defunct 20th Bomber Command and specialized B-29Bs optimized for nighttime pathfinding. Missions expanded to include mining operations in the inland sea and firebombing 58 smaller cities. With the Japanese air defenses effectively neutralized, B-29s began dropping leaflets 3 days before their raids, warning residents of the imminent destruction of their cities. At 2:45 a.m. on Monday, August 6, 1945, a nondescript B-29-45 MO with the serial number 44-86292 prepared for takeoff at North Field on the relatively unknown island of Tinian in the Western Pacific. One by one, the engines were tested, each illuminated by a spotlight to check for excessive smoke or mechanical issues. Unusually, this aircraft bore no flamboyant artwork, only the simple text, "Enola Gay," emblazoned on its nose. In the cockpit, Colonel Paul W. Tibbets, Jr., commander of the 509th Composite Group, occupied the left seat, while Captain Robert Lewis sat on the right. This group had been stationed on Tinian since June, eliciting curiosity from other units because they seemed to engage only in training missions and largely kept to themselves. In just a few hours, the mission of the 509th Composite Group, and specifically this plane, the Enola Gay, would become globally infamous. Heaving 75 tons off the runway, the aircraft began its journey to Japan. At precisely 8:17 a.m., while cruising at an altitude of 31,600 feet over Hiroshima, the world's first airborne atomic bomb, the Little Boy, was released. It detonated 2 minutes later at approximately 2,000 feet above the city, erasing a 4.5-mile diameter circle in the heart of Hiroshima. A second atomic bomb, the Fat Man, was deployed over Nagasaki on August 9th. Just 6 days later, Japan surrendered unconditionally, bringing World War II to an end. The Boeing B-29 Superfortress stands as one of the most iconic and consequential aircraft in military history. Engineered with advanced technologies for its time, it revolutionized long-range bombing capabilities and set new standards for aerial warfare. Its unparalleled range, payload capacity, and complex electronic systems were groundbreaking, giving the United States a significant strategic advantage during the latter stages of World War II. Yet, the legacy of the B-29 is a complex tapestry, woven with threads of military triumph and ethical dilemmas. It facilitated the end of World War II, but also ushered the world into the atomic age with the bombings of Hiroshima and Nagasaki, a moral conundrum that continues to be debated. The aircraft also led to advancements in aviation technology and strategy, laying the groundwork for future generations of military aircraft. Ultimately, the B-29 Superfortress symbolizes a transformative period in global history, encapsulating the ingenuity, bravery, and moral complexities of a world at war. Its role in shaping the outcome of one of the most devastating conflicts in human history ensures that it will forever be remembered as both an engineering marvel and a poignant reminder of the immense power and responsibility that comes with technological advancement.